MCAS review homework number 1, and more. In this video, I will go over the answers to the 2016 MCAS review homework number 1, and I'll focus on the ways to graph, including using slope-intercept form and intercepts, as well as interpreting slope and intercepts in a graph, and finally, how to solve a system of equations. Part 1 is graphing in slope-intercept form. A quick reminder that slope we represent with the letter M. We say that slope is rise over run, or the change in y over the change in x, which can also be written like this if we have 2 points that we're finding the slope between. A positive slope has an upward slant if you are going from left to right. A negative slope has a downward slant. A slope of 0 is a horizontal line. And an undefined slope is an x equals equation. X equals a number, and that would be a vertical line. On the homework, you were asked to graph 2 lines. Both of these are already written in slope-intercept form, which makes it more basic for us to do. Slope-intercept form is y equals mx plus b, where x and y are coordinates, and m is the slope and b is the y-intercept. When we go to graph this line, we can identify right away that since we have our equation in this form, our 4 is our slope and our 3 is our y-intercept. Similarly, our negative 5 over 2 is our slope and our negative 3 is our y-intercept. If the equation was not already given in this form, we would need to use inverse operations to isolate y. I've written my y-intercept as a point, 0, 3, because I know that the intercept is wherever we cross the y-axis. And then I can plot that point. Now I use the slope of 4, or 4 over 1, to tell me that my rise is 4, so I'll go up 4, and I'll move over to the right 1, because it's a positive slope. I can also go down and over, again making sure that I have a positive slope. And once I've graphed them all, I should connect them with a ruler. On the second one, we use the same method. My y-intercept was 0, negative 3, so my first point goes down at negative 3. And then I use my slope of negative 5 over 2 to tell me that I go down 5 and to the right 2, because I want it to be facing in the negative direction. And I can continue plotting as many points as I want, and then I can connect them. Another way to graph is to use intercepts. If you recall, the x-intercept is always on the x-axis, so it's always a number and then 0. The y-intercept is always on the y-axis, so it's always 0 for my x-coordinate and then a number. If you're given a graph, you can often read the y-intercept or an x-intercept from the graph. However, if you're given an equation, you can use what we just discussed to find this. So to find the x-intercept, we can substitute 0 in for y, and to find the y-intercept, we can substitute 0 in for x. When I do this, I find that my x-intercept is 6, so I can write this as 6, 0, and my y-intercept is 4, so I can write this as 0, 4. I can graph my equation by simply graphing these 2 points and then connecting them. I could have also isolated y, and I would get the equation that goes through these 2 points. I did the same thing in number 4, and I got that my intercepts were negative 5, 0 and 0, 4. So I can connect these points, to graph this line. Now we've looked at graphing from y-intercept form and also graphing from intercepts. Keep in mind, you can always make a table. And I mean this sort of table, where you choose your inputs, try to pick negatives, 0, and positives. If we had a fraction, we'd often want to pick multiples of the denominator, and we can make this table for any line ever. A table is particularly helpful if you have an equation like x equals negative 2, because you know that the x-coordinate is always going to be negative 2, and it helps us to remember to make a vertical line. Part 3, interpreting intercepts and slopes on a real graph. When you're looking at a real graph, it's important to know what you're talking about. In this case, it says amount owed in dollars and the number of months. And I notice that I have a positive slope, which means that as the number of months increases, the amount that Emily owes also increases. I'm asked for 2 things, the x-intercept and the slope. The x-intercept is where this line that I've highlighted in green crosses the x-axis. I know that the x-axis is down here, so they intersect right at the origin, which is also then the y-intercept. That makes the x-intercept 0, 0, and in words we could say that after 0 months, Emily owes $0. Remember that we want to talk about both the x and y labels. For the slope of this graph, we want to look at rise over run. I can pick any 2 points that are easy to identify, and I can count how much I rise by, in this case 300, and how much I run or move over by, in this case 6. This simplifies to 50, and my explanation is every month the amount Emily owes increases by $50. Notice that I use the word increases to indicate a positive slope as opposed to decreases, which would indicate a negative slope. And I mentioned both the months and the amount owed. I could have also identified the 2 points and written them over to the side, 0, 0, and 6, 300, and used my formula, y2 minus y1 over x2 minus x1, to find my slope. My next graph is comparing the amount of time that has passed in minutes to the number of tests left to grade. I notice that it's a negative slope, so I know that the more time that passes, the fewer tests there are to grade. This line crosses the y-axis at the point 0, 15. That means that at 0 minutes, there are 15 tests left to grade. It crosses the x-axis at 150, 0, which means that after 150 minutes, there are no tests left to grade. If I use my rise over run, I see that when I go down 1 test, I go over 10 minutes. That means that my slope is 1/10, but it's negative, so it's negative 1/10. Now to find the slope, I also could have used the 2 points that I easily identified, written them out as an ordered pair, and then found the slope. Notice that I always did the second point minus the first point for both the y and x coordinate to make sure that my sign was correct. So every 10 minutes, the number of tests left to grade decreases by 1. Decreases implies my negative slope. Now I've already found my y-intercept of 15, and I've already found my slope of negative 1/10, which means that my equation is y equals negative 1/10 x plus 15. Part 4, System of Equations. A system of equations is when we have more than one line on the same graph. When we have 2 equations, it's wherever those 2 lines intersect. That the solution to a system of equations, whenever the lines have 2 different slopes, is the point of intersection. If we have 2 parallel lines, meaning the same slope but different y-intercepts, and if we have the same exact line, meaning the same slope and the same y-intercept, then we have infinitely many solutions. Not all real numbers, because a point way over here is not a solution to it, but we have an infinite number of solutions on that graph. If we're given 2 equations and we want to solve them algebraically, we can use substitution or elimination, and I'm going to recap elimination for you. First thing you want to do is rearrange the equation so that your x's line up, your y's line up, and your constants line up. I subtracted 5y from both sides in my second equation so that I have some number x minus or plus some number y equals our constant number. Now, if I were to add these 2 equations together, I'd get 6x minus 2y equals negative 8. But I want one of my variables to cancel out. I notice that since I have a 2x and a 4x, if I multiply my entire top equation by negative 2, then I'll have a negative 4x and a positive 4x in my 2 equations. When I multiplied my top equation by negative 2, I didn't change the value of the equation because I did it to both sides. My new equation is negative 4x minus 6y equals negative 24. Now, when I combine these 2 equations together, I get 0x, which is exactly what I want, minus 11y equals negative 44. I'm able to solve this because it's only one variable, and I get y equals 4. Now that's not my solution, because my solution is going to be something 4. So I need to take this 4 and substitute it back into any of my equations, typically the original equations, in order to find what x is. I chose the second equation. 4x equals 5y minus 20. So I get 4x equals 0, which means that x itself has to equal 0. and my solution is 0, 4. Notice that this was the same set of equations as we saw in questions 3 and 4. And sure enough, our solution was at the point 0, 4. We could always check this by substituting 0, 4 into both equations to make sure they come out true. This concludes the first recap homework video for MCAS in 2016. If you still have questions on any of the topics covered, make sure that you ask.